These notes are on the topic that you covered in section 2.6. It's which form is best for linear and exponential functions. Basically, what special things do we get to see from them? So we're going to look at an example of an equation, y equals 3/4 x minus 5. The name for this type of equation is slope intercept form, which we often see as y equals mx plus b. And the special powers that this equation has is that it gives us the y-intercept, which is the letter b, which we write as the point 0, b. And in our example here, that would mean we'd have the point 0, -5. We then, from this point, use our slope, which is the letter m, which in our case in this example is 3/4. Remember that slope is rise over run, so this slope means rise 3 to the right 4. And I do that until I have several points. So continue slope and then connect the points. Our second form that we're going to look at is when we have something written like this, y equals 3/4 x minus 5 plus 2. This form is what we call point slope form. And we often see it as y equals m times x minus x1 plus, sorry, I've run out of room here. I'll just extend this box over a little bit. So x minus x1 plus y1. The powerful part about this form is that it gives us a point. So we start by plotting the point. And the point is x1, y1. And so in this example, that point is going to be 5, 2. And then from this point, we use our slope, which again is represented by the letter m. And so in this case, 3/4. So we rise 3, right or run 4. And then we continue our slope and then connect the points. Our third form of linear equations that we have seen is when we have the recursive. So like f of 0 equals 3, f of x equals f of x minus 1 minus 5. And this is the recursive. And in the recursive form, our f of 0 equals b, and our f of x equals f of x minus 1 is really our plus m. And so for this one, we start by plotting the b, which is our y-intercept, or the point 0, b. In our example, it's 0, 3. We then, from this point, use our slope, which is the letter m. And our slope in the recursive appears as what we're adding and subtracting each time. So our slope here is minus 5. And then so that is going to be, instead of rising 5, I'm going to go down 5 to the right 1. And then we continue our slope and connect the points. So just to kind of summarize here really quickly, we have 3 forms: slope-intercept, point-slope, and recursive. In each of these, we have a point. And in each of these, we have a slope. And so once I have a point and a slope, I plot the point and then use my slope in order to graph the line. The second types of functions that we have seen are the exponential functions. In the exponential functions, the information is given in 2 different forms. So our first example is y equals 2, 3 to the x. And in our second, our example is f of 0 equals 2. F of x equals f of x minus 1 times 3. And the names for these are explicit form, which we see as y equals a b to the x, and our recursive form, which is f of 0 equals a, f of x equals f of x minus 1 times b. Now, in both of these, the method for graphing the equations is very similar, and so we're not going to really break them up. Instead, we're just going to note that in both of these, in both forms, you plot the point 0, b, 0, a, and then from there you multiply b times a as you move 1 step to the right.